Hey there. In this couple of sessions, we will use the method related to the time series. Note that for time series, we need to install the Microsoft.ml.timeseries package from the NuGet. We have already done in the previous session, so we does not need to do it again. In this session, we will detect the change point in the data related to the time series. I have already created a new folder for session 56 and created instance of the ML contacts. Here I have created an input model. It has just single property, name, value, and I created a constructor to set that. And in the result model, we have property name prediction. Let's call the detect change point from the execute method and create this method. I have already written the C# code to add the dummy data to generate the data view. So let me paste it here. Now we need to create a pipeline called the detect change point by SSA method of the transforms catalog. Here SSA stands for singular spectrum analysis. It is a powerful tool for analysis and forecasting the time series. Output column name will be prediction. And input column name will be value. Confidence for the data view will be 95. Using the change history length, we can specify the size of the sliding window for computing the p-value. Let's use the 8 here. Training window size specify the number of points to be used for the training. Our window size is a 4 and loop will iterate 5 times. So write the 4 multiplied by 5. Seasonality window size specify the largest seasonal data in the input time series. Here we have used the loop. So all of them have the 4 record. So it will be 4. Create a model for this pipeline. Here we need to use the create time series engine instead of the prediction engine. In the print helper, I have created a method in which we need to pass the time series engine and list of index. Within that, we will predict the value for the index and print the prediction detail generated by the estimator. Call that method. Pass the time series engine. And list of index, I am passing the 1, 2, 3, 4, and 5. Save the file and run the project. Here index is a value that we have passed. And let's specify that it detected change point here or not. P-value indicate that computed row score for most recent row score value in the timeline history. Marginal score is built on the p-value. It used to detect the changes of the distribution over a stream. Alert is an important flag, as this flag is used to indicate whether changes exist or not. Here any index does not have the changes. Let me pass the 100, 200, 300, 400 and 500. Save the file and run the project. This time here we got the 1 in the alert, which means index 300 has a change point as per the SSA. Let's see what we have learned in this session. In this session, we have used the detect change point by SSA for indicating the changes in the time series data. Note that we need to ensure the NuGet packet of the time series. In this method, we need to pass the change history length, training window size, seasonality window size, and create the time series engine. See you in the next session.